Welcome and thanks for joining early. We'll get started at the top of the hour as we wait for everyone to trickle in. Hello, everyone. We'll get started in just about a minute. Thank you for your patience. Hello and welcome. Thank you for joining our Sonar Live webinar, Taking Control of Your Applications Architecture in the Age of Agentic Development. If you've previously attended any of our other webinars here at Sonar, thank you for coming back. Today, our presenters will be walking you through how to take control of your software architecture with SonarQube, not only for an individual application, but also from an overall system point of view, including when doing agentic development. I'm Robert Curley, and I'll be your moderator today. I'm excited to have Gabriel Vivas and Denis Troller presenting today. Behind the scenes, answering your questions is Chris Cheggi. Gabriel is a product manager at SonarSource. Before moving into product, he worked as an engineer in cybersecurity and public safety for Airbus Defense and Space and Vinci Energies in France. Today, his focus is on making software architecture accessible to everyday developers and seamlessly integrating it into modern workflows. Denis is a product manager at SonarSource. Before joining Sonar 3 years ago, he worked as an engineer in industrial control and data acquisition systems in France. Today, his obsession is making agentic development safe and efficient by seamlessly guiding agents and verifying their output. Before we begin, let's go over some quick housekeeping points. This session will last about 45 minutes. We may go over a little if the Q&A, is cool and everybody's asking awesome questions and that goes well, but we'll try and keep it to 45 minutes for you guys. So including that Q&A, you're invited to submit your questions during the whole webinar. You don't have to wait till the Q&A session at the end. There's a Q&A section in the webinar here. There's a tab up on the right, Q&A. You click on that, you ask your questions there. Again, we'll be answering those. We'll also have a live Q&A session at the end with Gabriel, Denis, and Chris, and myself. So I'll be asking your questions live. Please don't ask questions in the chat area. I know it's tempting, but let's try and keep the questions to the Q&A. That's where we're watching those Q&A questions that you bring in and we're answering them. It's a great little handy tool. This session is being recorded and we'll send out a link to the recording via email to everybody who signed up for the webinar, even for folks who didn't attend. We don't send our slides out, but you will get a recording of the webinar. There will be a poll during today's webinar. Please participate in the poll. It's really important. The more that people enter the poll and submit, the more interesting results. So it's pretty fun. And then at the end, there'll be a brief survey. And we really appreciate your feedback in the survey. That helps us guide our coming webinars. So let's get to the webinar. Gabriel, over to you.
Thank you. So today we'll go over 3 main points. I'll try to go through application architecture as we understand it here in Sonar. You'll see a demo of how it works in the product. Then Dennis will pick it up for the Agentic workflow, a few slides also with a demo. I will actually include the system architecture topics right ahead up front, so that way we keep it tight and we get a little bit more time for the Q&A. So let's get started. What do we mean by application architecture first? Because when you throw around the term architecture, people might think it's the whole system architecture, or there are many levels of architecture. So here, for our main scope, we want to talk about application architecture. So think about as your repo, where you have your code, how it works inside. So the internal organization of the application. And this comes mainly in 3 parts. The structure, which is how are you ordering, grouping the components inside your system. So this is the basic element of architecture. If you have Java, it's going to be the packaging system. If you are having TypeScript, it might be your TypeScript modules or the folders you're keeping them in. And this is the fundamental unit of your organization, internal organization of the code. Then the relationships are which components depend on each other, which are using each other. And this is very fundamental to how you are able to understand it. These relationships can be very local. So a few components talk to the neighbors, to the children, or they can really span across the whole project. And if you ever heard the idea of a spaghetti code base or a big bowl of mud or a hairball, this is really where it happens when everything depends on everything, and touching some parts of the system or the application affects the rest. And finally, interface design is this idea that you can decide at the local level how a component should interact with the rest of the system. So some programming languages have the notion of visibility, or you can expose some things and not others. But broadly in the system, this means that you don't want everything talking to everything, so you want to restrict that. So these 3 core concepts is what we're going to help you manage as the real foundation of application architecture. And the idea is that architecture gives you control over the integrity of your application, way beyond what you can achieve only with the code level. So it's a higher level way of thinking about your application that gives you more leverage. So this is what we mean here by application architecture. Now, what is actually needed if you want to control AI agents at a higher level? Because if you're using AI agents with your project, in your applications, you've noticed that you accumulate big changes, big pull requests, and reviewing that is a lot of effort. So if you wanted to control that, manage that at a higher level, what is needed? We believe you need at least to be able to discover the real architecture that is being built. So what are those components and that structure, that hierarchy of things that is actually being built? You need to be able to see that, to understand it. And then also those relationships that are being spawned across the code base. So you need to discover what we're calling the current architecture, what you have. That's the reality of what you have. Knowing that helps you to actually define and enforce an intended architecture, which is presumably not exactly the same. It's rare that you have a system that is exactly as you would wanted it to, especially when you're working with AI. You're starting to get all sorts of deviations from your intention, and you will need a system that allows you to have a formal definition of that and pick up on those problems and enforce AI to not go away. I mean, AIs or developers. Once you have that, that's already the big part of it, the foundation, but you would still want to be able to pick up on architectural flaws and smells, like tangles, cyclic relationships between different components. and other architectural smells like split responsibility and these other things. And finally, you would want to have all of that in a workflow that makes sense. Then you can actually solve and act on it, because if you get a super complicated view without any way to act on it, that's not really helping you make any progress. So the question we want to bring to you is, does your agent know the architecture you want to achieve? You know, this high-level organization, these high-level relationships. And do you know what your agent is actually generating when you prompt it to build stuff? It's not always doing exactly what you hope for. So how are you managing that? This is the real heart of what we're trying to show you today. And those are all my slides. I'll go ahead through the demo. Just bear in mind these key points about application architecture. So I'll switch right away to the demo. Let me change what I'm presenting. I'll share my window. And here we're looking at SonarQube. This is SonarQube Cloud. And I just scanned a project that I found. I think here it's called GC Toolkit. It's made in Java. And I'm greeted with this dashboard automatically. And let's go ahead and look at that current architecture we were talking about. So what we see here at the high level are the top level modules that the application has. And they're organized in a very deliberate way from left to right in the direction that dependencies flow. If I choose any component, I am able to see the real relationships that are tying it to the rest of the code base. And I can zoom in to see exactly the modules, the packages, the sub-packages, and even the class level of how this code base is held together. You can see it's very reactive. You can zoom in and drag to navigate. Not all code bases are this simple. Some of them have very messy relationships. I can show you this big module has a lot of relationship with the rest. So we build this high-level view that reduces the number of lines without losing any information. So when you dig in, you can still see the components that are highlighted, in this case, classes. Those are the ones involved in the relationship with this module on the right-hand side. So that's how we're showing the relationships here in SonarQube. One thing that I want you to pick up is that this representation is unlike most representations you have seen about code. This one has a true meaning. It's semantic. So because the relationships and the components are laid out in a meaningful way, the relationships are flowing left to right. That means that things that are on top of each other don't have relationships between them. So I know that none of these classes depends on the ones in the same column. And the same principle applies at the higher level. This package has no relationships with the one above. And all the way up to the project, these 4 modules at the left have no relationships between them. And that gives you a lot of information in a relatively simple view. And there's more. So if vertical things are not related, that means they're decoupled. But when they're more horizontal, like in this example, it means there are dependencies flowing from one thing to the other. They're getting in from the left or from the right-hand side, and this package is more connected to the rest, making it more cohesive. So typically, you would find this in the internal system business logic, and the more vertical things, you will find them at the end for APIs. I'm pretty sure this should be an API, an event API. And this allows you to get literally a picture of any code base. Even if you don't know it in detail, you can already get a sense of how complex it is, how big things are, which are the bigger modules. Notice that this module is mixing up very horizontal things with very vertical things. And you can do this while you're working with AI as it is creating stuff. you can see what is actually being done and how things are connected to each other. So here you can see a little bit more. So this is what we're calling current architecture in SonarQube. Once you get a sense of what you have, you can actually start making some decisions of what you want to preserve or what you want to enforce. And we do that through intended architecture. What it means is that not only SonarQube is able to reverse engineer what the code structure and relationships you have, but we also allow you to define quite easily here with a convenient generate draft, a high-level architecture that then can be enforced. So SonarQube was smart enough to know that these top-level modules have relationships going in one single direction. If there were any cycles, they were removed because they're not going to be helpful for the high-level architecture. If you don't want this level of detail, you can remove some of the components. You can add them back with just a simple click and create relationships with drag and drop. And just like this, you can create a very high-level architecture for your project that SonarQube is going to be able to enforce. So go ahead and save this, and we can navigate back to where we were in the dashboard to see how that translates into something more actionable. So we saw the current architecture, the intended one, and now SonarQube is able to, I'll zoom in a little bit, is able to pick up the deviations between the current and the intended. In this case, we picked up 3 relationships at a high level that shouldn't be there according to your intended architecture. So we list them here at what depth they're happening. In this case, they're at the top level. And there's a number of code level issues that relate to this relationship. So because all that we're doing in architecture is at the high level, it means you can also go down with SonarQube to the specific lines of code that are creating this problem. So SonarQube will raise issues from the moment you have an intended architecture, will raise the issues first to let you understand the gap, as we were seeing, but also to make it actionable right away. So I showed you some examples of structure deviations. These were relationship deviations. And I also want to show you a few more things. SonarQube is, even if you don't have an intended architecture defined, it is already capable of picking up some problems in the architecture, like tangles, which are groups of cycle dependencies. So here's an example. You see a chain of classes, and there's here one relationship hopping, and there's one here going back. So presumably, we don't want those kinds of relationships that go back. Oh, I think I messed up the current permissions. Let me get back in there. Here you see, I can request the removal of this edge, of this relationship, and this will raise a SonarQube issue. So this will be requested to be removed from the code, and it will raise up as a normal issue, just as the ones for the other deviations. There's more here to be described. I won't go in depth through all of those, but just to give you a sense of what SonarQube can already do for your architecture, for your application architecture. Just before going to the next topic, I wanted to show you a little bit more of what can be done in a slightly more complex example. Here I have also an intended architecture, but this one is a bit more involved. I've defined multiple levels deep, and I can see that some of those components have a description, for example. So this is helping both architects and developers keep track of what this is supposed to be used for. So here you can say I can edit this description. We can continue adding deeper levels of structure and manage it. But I wanted to show you something else. In this case, in this component, I have this relationships and this children defined, but I want to enable the interface design management. And this allows SonarQube to pick up on the visibility of things, to give you more control of what you want to expose or not. So not only the relationships at the high level, you can also say, hey, anything that tries to access this component should go through this aggregator component. The rest will be hidden, effectively not accessible. So this works across the languages we support for Java, C#, TypeScript, JavaScript, Python. So it's an abstract idea built on top of the architecture of the language. And if I see that in a compact view, I will only show the aggregator that is being exposed. So we have a bunch of nice resources. We'll share the link with you in the chat. A lot of small videos to dig deeper into all of those features. We try to keep them very short, like 1 minute demonstrations, and also some blog posts if you want to dig in. And that's just to give you a taste of what we have in SonarQube. So I'll go back to the slides. There we are. So that was a demo of application architecture. And I want to just touch a word on system architecture, because as you're seeing these nice diagrams of how the application is made up, you're probably thinking, okay, but what about all the other things that are across the process boundary, my database, a queue, or something else? So we're working on this too. So this is coming soon. We're building an extension to what we already have in SonarQube. And this is going to bring the ability to map your whole system automatically, discover how your applications depend on each other and how they relate to those system components we were talking about. And it's also going to work across programming languages as our current application architecture future. We'll bring in, maybe you got a sneak peek there of patterns, architecture patterns across the organization. So you define a small piece of intended architecture that you want to use across multiple projects. So this is part of what we're building beyond the application boundary, just to give you a sneak peek. And we have a nice poll for you. I'll let you. Oh, you're already answering. That was very quick. So these are in the questions are okay. I see the answers coming in. I'll give you some moment to finish. Excellent. So AI and agentic code use regularly. Hey, you're already using architecture features. That's great. Okay. Seems to be stable now. It's very cool. Thank you for participating in that quick poll. Should we move on? Oops, take it away.
Thank you, Gab. So, excuse me. Pardon me. So what do we mean by agentic workflow? When you use an agent, what happens is that it's going to go into usually 3 stages. When you ask it to do something on your code base, typically to solve a task, an agent will first explore the code base to learn about the current state of the code base. Then it's going to move on to planning, which is where it will take the goal, the prompt you gave it, plus the learnings of the explore phase and any constraints it might have, and we'll get to that. And then it's going to move on to the implementation, which is generate the code according to the plan. Generally speaking, what you want is that at the end of the implementation, you want the code that it generated to already conform to your expectations. So what does that look like? If we look at the next slide, we're going to see that, okay, we have an agent in the middle. We give it a prompt. It's going to go through the explore, plan, implement phases. It's going to generate code that's going to come to your review, and it could come straight into your terminal if you're using an agent locally. You could even ask it to push straight to GitHub to get a PR review, and that's when typically you will discover that, yes, it did solve the problem, but it did not do it according to what you expected. It violated architectural constraints, typically what Gab showed you just before. And that's when you have to reject the result, and you have to reprompt, adding that information that no, you should not reach out to that object, that class. This is not allowed. You need to do it differently. And what is the outcome? Well, the outcome is basically that all the tokens that you spent coming up with that first answer are pretty much wasted. And that's definitely not something you want in this day and age, with the prices of tokens going up and up and up for everyone. So how do we solve that problem? Well, we still have the same basic workflow because an agent doesn't change. The main difference is that on top of the prompt, we inject information about the architectural constraints. And by doing so, we prime the agent to generate his answer in the constraints that we give it. And the goal is to remove that violation and get rid of the rework, saving obviously token and improving your velocity because you will be able to merge faster. So what we're going to do is we're going to actually look at a demo to see what that looks like in practice. What I have here is a simple open source project, just like Gap, just a different one. It's still Java based because why not? It looks horrible, like a lot of projects when you first analyze them, but that's not the problem. That's not the issue right now. So because we've analyzed it, we do have the actual architecture. It's a bit more involved than what Gab showed. The actual spaghetti is actually very visible here. And what I did is I took the time to define an intended architecture from the top level modules of the application. Why do I do that? Because that's how I impose governance over my code. I explain what I want. And that has two added benefits. One, SonarQube will be able to actually verify that any code that has been added to the code base conforms to that intended architecture, which is what Gab explained. And second, I can leverage that information, that graph that's been defined here, that says that this is allowed to reference this, and that, but nothing else. And by taking that and giving it to the agent, I should get a better response than if I did not. So what does that look like in practice? Well, I'm going to head up to my terminal for my demo. This is Claude. I've actually added to Claude, I integrated the SonarQube CLI with Claude. That's the simplest way to benefit from agentic tooling from SonarQube. Once I've done that, which is basically just typing a very simple one-line command, it's ready to go. It's got the tools for context augmentation, which is the actual feature I'm talking about now, ready to be used. I'm going to give my agent a prompt, which is basically a feature request that I've taken straight from my open source project, asking to add a web API. And what's going to happen as my agent is going through the motions that I've described, it's going to explore, it's going to ask questions from SonarQube. One of those questions is, what is the intended architecture? It's going to use that information to formulate its plan. And once it's done, it's going to actually come up with the right answer. And because this is a very nice demo, I realize that I've used the wrong window. and I'm doing it without the tools. So at least you can see what happens when I'm doing it without the tools. So I'm going to switch to the other one, where I actually have the proper tools, and I'm going to do the same thing. This is what you call in the jargon the demo effect. Right. On this one, I do have my tools loaded. I can see I'm using the Sonar skill, and that's where you can see that one of the first thing it does is ask about the intended architecture of the project. It also asks about guidelines, which is another way to guide the agent through what it does. And then it uses other tools that we have available to navigate the code base more efficiently than just doing the grep and find that you might see your agent usually do when it's exploring the code base. So now it's got the information that it needs. It's going to actually formulate the plan, create its tasks, and start implementing. It's happy. And it's going to start implementing. Right. Now, what you can see here is that, okay, we detected an issue, which is probably a string duplication, I think, or something like that, so an import. And it decided that, okay, it needs to check if what it wants to actually do in response is architecturally allowed. And looking at the architectural constraints, it sees that no, it is not listed as an allowed dependency. Doing what it wants to do would violate the architecture. Instead, it will just use the message type string instead of reaching out to import it from another module. And then it's going to continue. It's going to finish implementing the task. And what that means is that if the agent had actually done that, what it wanted to do, when the PR reached the CI, you would have had a SonarQube issue linked to a violation of an architectural constraint. And that's exactly what I described before. That's exactly what you do not want, because then you have to ask your agent to redo the whole process, and you've wasted time and money. Instead, the agent considered the constraints, and it actually generated code that aligns with the expectations. Now, you're going to tell me maybe that you can achieve that with a few MD files in your repository. And that's true. But who wants to maintain MD files? Why would you maintain MD files that you cannot leverage for verification when you can actually leverage directly SonarQube for both guiding your agents and verifying the code? And that is the power of defining your intended architecture inside SonarQube. It's the minimum amount of effort to ensure that the code actually conforms to your expectations. And God knows that it's not that easy to achieve even with humans. So that's it in a nutshell. That's how you get agents to actually preserve the architecture that you've defined. And with that, I will let Gab continue.
Yeah, I can take the screen back, Denis.
Yep.
Cool. So that was the Agentic workflow demo. And we have an upcoming webinar, if you want to register too, about governing technical debt when authors are agents. So in this same line of thought, feel free to snap this so you have it ready. And I'll leave it just a few seconds while everybody joins back. And then we'll go into Q&A.
Thank you. That was great. Wow, thanks a lot, Gabriel and Denis. I really, really like the part about how the layout of the live visual map of your architecture shows you things about the relationships between components, such as like the row width and the column depth showing higher and lower cohesion. I think that's pretty cool. And of course, Denis' stuff about the agentic stuff, that's just really hitting on point with what's happening in the agentic development world. So I'm really excited for all this stuff. But let's get at everyone's questions. There are quite a lot of really good questions in the Q&A, and let's see here. I kind of combined a bunch of stuff together. So a bunch of people asked stuff about availability. You know, is it already available? Can we use it today? Is it available in the on-prem version? So that SonarQube server. How can we check whether our SonarQube Enterprise subscription has access to the feature? So maybe Gabriel, you can handle that one. Do we lose Gabriel?
Okay.
Or how about Chris? Chris, do you want to answer that one?
Yeah, sure. Is this it's available? Is this already available? Yes, everything you've seen today is available in cloud as part of the core product. So you should be able to go ahead and use that if you're in cloud. On-prem is on its way. Gab, do we want to be precise about the date for that? It's coming soon, I believe.
Yes, it will be. So just to do a small precision here, we're showing actually two things, right? We're showing the core architecture features that you have today available in SonarQube Cloud in all plans, and that will come in the next big release of SonarQube Server later in the year. And we also showed the second part with Denny was demoing, and you can talk about this, Denny.
Sure. So this second part is part of the context segmentation product that is today in open beta on cloud for all paid plans. So you can try it for free with no limitations.
Awesome. That's exciting to know. So in all, just to repeat, so make sure I'm clear, in all SonarQube Cloud plans, including the free plan and paid plans, and coming soon to SonarQube Server.
Yes.
Cool. Let's see, what's next? There are quite a lot of questions about where the visualization works. So I'm going to go through a bunch of similar kind of questions. Does it work on microservices and monorepos? Does it work on whole SonarQube portfolios or cross-project architecture? Does it, example, find relationships between client requests and endpoints, or IAC code, where it combines with code of projects to build or release? And then another question, similar question about monorepo versus polyrepo, where a single project is distributed across several repositories. So I think that's, Gabriel, that's a good one for you.
Yeah, I can take that. So we had this separation between application architecture, which works essentially inside a repo. It does work across the languages, even inside a repo. So if you have a backend in C# and a frontend in TypeScript, it will work. You will be able to see all of that. Then for cross projects, monorepos, you still see them as, if you're using the monorepo functionality of SonarQube, for SonarQube, these are effectively projects. So you will be able to see how they work internally. But to answer more about the cross project, this is the part I was talking about that we're building as a system architecture, as we're adding on top of the existing functionality. So we're really eager to work on this and make it available to you, but it's for now in preparation. So it will come soon.
Very cool. There were also a few questions about supported languages. It was shown in Java. Does it work in C#, TypeScript, Kotlin, C++?
Currently, it's available. I can take that. Gab seems to be having technical issues. It currently works in for Java, C#, TypeScript, JavaScript, Python. Other languages to follow. The bulk of what you're seeing in the UI is, in fact, language independent. It's a matter of plugging in the data from the different language parsers. And so all of that is on its way. And we're taking note of the requests, that specifically what people are looking for. Feel free to, let us know if there are particular languages you're interested in.
Okay, yeah, good to know. And that's probably a good time to remind people that these questions, we love them, keep them coming. If we don't get to all of these questions, go to our communities and ask the questions. That's a good place to ask for stuff like languages so people can upvote things, and that'll help our prioritization of our backlog. Okay, let's see what else. Is context augmentation available for any agent? It sounds like a Denis question.
Yes, actually. So we have very simple integrations available for Claude, Copilot, Codex, Cursor. But it can work with any agent because there's a version of it that is delivered as an MCP server. So all you need to do is run the MCP server on your local machine, and you can benefit from context augmentation from any agent that supports MCP. And I don't think I know of any coding agent that would not support MCP in this day and age.
Yeah. Yeah, that's a good point, right? So we have some specific integrations with IDE, like Agentic IDEs, but also as a backup, any kind of MCP integration would work. There was a question about someone tried to set up the MCP server, but it required every developer to have admin access. I don't know if that's too specific. I suggested they go and ask that in community to get very specific support on that, but I don't know.
Probably. The only thing is that the MCP server today requires Docker to run. So that might be the main problem. But there's a much simpler way if you're using one of those agents that I talked about. The simplest way today is to download the SonarQube CLI, which is GA, and use the Sonar integrate name of your agent and your project key, and you'll be good to go.
Oh, very cool.
And there is awesome absolutely no dependency in that case beyond the SonarQube CLI.
That's awesome to know. Right, thanks for that. Yeah, so look up the SonarQube CLI and find that means to integrate. Hopefully that'll help if you're having a problem with the MCP server. Let's see, what else? There was a question about memory consumption in SonarQube, but I don't know if that was related to specifically the architecture or any of the agentic stuff.
I mean, we can start for architecture. So the analysis, the architecture analysis happens at the same moment the regular SonarQube analysis happens. And it does that a little bit, but it's in a single percentage digits implication. And it's been running, if you're using SonarQube, it's been running since the start of the year already. So if you didn't notice any disruption, you can expect no other disruption. It doesn't add any more. When you add an intended architecture for all the checks, it doesn't really affect significantly the performance. You also don't need to do any additional setup. So if you already are scanning your project with SonarQube, it will just work.
Very cool. Let's see. There's a question about dependencies, like what dependencies are detected by the architecture capability, and how is the visualization built?
Okay, so the dependencies, I mean, mostly static dependencies. So like code calling other code. We don't do, of course, all the dynamic dependencies. So there are limitations like reflection. these kind of things. If you're doing super advanced hacks to wire dependencies, that won't be picked up. We will improve the product as we go, but we find that even with static dependencies, you get a really a good picture of what you're dealing with. So that's what SonarQube detects. And then the second part of the question about how the visualization is drawn, well, it's automatic. Just after the analysis, you can go right away to SonarQube, and it's completely automatic. You just are instantly available to use it and see it. You don't have to do anything more manually.
Awesome. Okay, I think we should wrap it up. We're getting to that 45-minute point. Thank you again, Gabriel and Denis, and thank you, Chris, for helping answer questions and jumping in and answering some live. That was great. Thanks to everyone who submitted questions. I'm sorry if we couldn't get to everyone. Again, go to our community, ask your questions there. It's a great place to ask your questions and get really good responses. They're very smart people over there answering questions all the time and helping people out. And finally, again, a survey is going to show. Please complete the survey. It really helps us. It helps guide our future webinars. And that's it for today. See you guys next time. Thank you.
Bye.
Thank you, everyone.